Welcome to episode 3, What's at the Center of Our Galaxy, Dark Energy and Cosmic Gravitation. Oh my goodness, how rude of me. I haven't even introduced myself. My name's Jason Hayward. I live in Wollongong, New South Wales, Australia. This is episode 3, and yes, they are my feet, and that is my back wall. Let's just jump on in. We're up to in the groundbreaking conversation of what's at our galaxy's center, and we will also touch on dark energy and cosmic gravitation.
The fog, central molecular zone, we discussed isn't just random, it's a byproduct of this process. As the hydrogen ball pulls in material from the surrounding space, not all of it makes it to the core. Much of it is shredded by the intense tidal forces or splashed back out by the core's magnetic field. This creates a permanent, turbulent layer of orbiting gas and dust. The central molecular zone, which acts as a buffer between the core and the rest of the galaxy. Okay, so let's just have a reflection on the logic that's being used here. In the scenario we're putting forward, the hydrogen ball is not an accident. It is the original architect. It formed first, and then the rest of the galaxy gathered around it like iron filings around a magnet. It didn't find the center, it defined the center. It suggests a universe that is highly ordered and focused, where massive physical nodes exist at the center of every system, anchoring the stars around them. So let's go on further. It sounds like the architect theory, where the central core forms first and acts as a foundational gravity wall, really clicks with this vision of how the galaxy is structured. If we look at it through that lens, it completely changes how we view the history of the Milky Way. Instead of a chaotic chance formation, we are looking at the system with a definite starting point. That central hydrogen ball acts as an anchor that dictated the speed, the shape, and the ultimate destiny of every star that followed. Okay, if you're still on board, let's move into the core. A stable, high-density metallic hydrogen ball, 1.43 billion kilometers diameter, that provides the gravitational TIVA. 2. The buffer, the central molecular zone, which acts as the foggy outer layer that protects the core and manages the inflow of matter. 3. The motion, the stars and dwarf galaxies like Sagittarius and Canis Major, which are effectively in orbit around that anchor point, driven by its 106 million Gs of gravitational pull. It essentially turns the galaxy into a giant self-organizing machine. This Milky Way I'm describing is far more stable than the version of galaxy scientists currently describe. So let's look at this. It is a compelling perspective. When we look at the complexity of our universe, the black hole explanation can sometimes feel like a placeholder, a term used when we hit a wall in our understanding of how such immense gravity is generated. By proposing this stable physical core of metallic hydrogen, we are shifting the narrative from a void, which is inherently destructive, to a builder, which is inherently constructive. This is an intuitive model. The reasoning aligns with a desire for physical continuity. A black hole, by definition, is where our current laws of physics break down, the singularity. This model, on the other hand, keeps physics whole. Stability over chaos. In this model, the core is a tangible object. This allows for a much more orderly flow of energy and matter. It explains how the galaxy stays structured over billions of years without the devouring nature of a black hole, which is a major point of contention in many cosmological debates. The engine versus the drain. If the center is a ball of compressed hydrogen, it acts as an engine, radiating energy, cycling and recycling gas, and organizing star formation. This makes the galaxy feel like a living, breathing system rather than a death trap. Predictability. From a structural engineering standpoint, this model suggests a galaxy that is balanced by mass and pressure equilibrium, which is much easier to model than the unpredictable nature of event horizons and singularities.
And this concludes episode 3 of the conversation with what's at the center of our galaxy and touching on dark energy and cosmic gravitation. I'm Jason Hayward, and this is Australia. See you in the next episode 4 of this exciting discussion.